Hey folks, welcome back to our channel. My name is Nigel and this is my dad Roger, and this is Offgrid Van Life, where we look at van conversions, lithium iron phosphate batteries and everything in between. Basically, we want to help you to convert vans and build awesome batteries and electrical systems for your van, so that when you hit the road and find adventure, then you can power whatever you need to, whether that's an espresso machine or an induction cooktop or whatever it is. Hopefully you'll find something helpful and valuable on our channel here. So today we've got a long awaited video. We've had people asking for quite some time now whether we've used the latest Junctek amp meter for electrical systems. So if you followed our channel for the last 6 months or so, you'll know that we've talked quite a lot about the Junctek, about the Victron smart shunt and various other amp meters and things and ways of measuring how much charge and how much capacity you have in your battery, and also how much you've used and all those sort of things. There's a bunch of useful tools that you can put into your van conversion or your boat or whatever it is. And so in this video we're going to be unboxing and looking at this guy. So this is the latest Junctek that we bought to try out. We'll talk through some of the details of this as to why it is quite promising, sort of on paper, what they promise and stuff like that. But essentially you have a display that you can see what's happening on your battery, and you also have an app that you can see on your phone. So supposedly you get the best of both worlds, in the sense that you get the functionality that the Victron smart shunt has, but you also get a display that you can put up somewhere in your van. So we're going to be connecting it all up here, doing the unboxing with the Junctek, connecting it all up to one of our Ops 280 batteries here. We've got a 3000 watt Guayandel inverter over here, which we're going to be running an electric heater. So we're going to get that all connected up. We're going to be running the Junctek alongside the Victron smart shunt. So we know that the Victron smart shunt is accurate. So we're going to run them side by side to measure how much is drawn from the battery and run some comparisons, and then give you an idea as to whether it's good or bad. And the Junctek have also had a problem recently, which we've highlighted and we've spoken about on the channel in previous videos. So hopefully that's fixed, but we'll start unboxing it now and then we'll take you through it.
So just to take you through, in a previous episode we did a review on these Junctek shunts. So this is, if you like, a smart shunt. It has this little display, and it has this unit here that you attach, you put into your negative line from your battery. So we did some reviews on these ones, and to be fair, fairly scathing review. We had contacted Junctek to complain about the fact that they introduced an error into something which was previously working quite fine, actually. So today's episode is not about looking at these Juncteks. I do want to have a look at and see if they have corrected the error in this. But Junctek, following the comms that we had with them, were kind enough to send this unit. So this is let's try and find the model for you. So this is the model KG140F, whatever 140F stands for. I'm not sure what capacity this can hold. I mean, we wouldn't go for anything that does less than 200 amps anyway. But yeah, so the idea is Junctek have kindly sent us this to do a review following the negative review of the other Junctek, the cheaper one. And as Nigel said, in theory this combines the best of both worlds. So this is our tried and trusted Victron smart shunt, which is spoken about quite a lot in forums, etc. This is our go-to when we want to check the accuracy of another smart shunt or something like that, and this is pretty good. So this works with Bluetooth, an app on the phone, and what we're going to do is we're going to connect this in series with a new Junctek. So let's start having a look at what is actually in the box of this KG140F. I'm hoping that it is capable of a fairly high capacity. If not, not sure what you would actually use it for if it can't actually cope with the inverter load. So let's have a look at what we get in the box now. The installation guide, not surprising. So let's see what this is. Probably the display. So if I'll no, this seems to be some sort of a comms unit. So it says here it is it just says voltage current measuring module. It's got a whole lot of connection points over here, and it's got a few plugs that can go in there, plus a few other little plugs that can go in over there. So we'll see what this is, but I suspect that this could be the comms unit or something like that. Anyway, so that's one of them. Let's look at the next little item. This is very light, so this looks like it is just a simple display unit. That's fine, that's great. It's got a little plug at the back, so obviously you can plug it in. I'm not sure where you power it. Obviously you power it from this plug at the back, and probably put this somewhere in your van or your boat or whatever you've got. And that's cool. we get to the shunt itself. So let's open this up and have a look at this. Not too bad. It looks like it's the higher capacity because, and I say that because it's got loads of fins here. If it was a very low capacity, say 50 amps or something like that, you'd find that there'd only be 1 or 2 fins here. When I say fins, these are actually resistors. So the way that this works is it passes current through and it measures the difference in voltage from one point to the other. So across this, because these are resistors. So knowing the drop in voltage and how much is actually flowing, it can work it all out. So that's the basis of one of these smart shunts. So this is quite elementary. You'd mount it somewhere that you could put it into your negative line of your battery. In previous ones, Junctek have worked on 8mm lugs, so we're going to have to redo some of our cables because they've now moved up to 10mm, as I can see here. So 10mm. One of the things that occurs to me immediately that I don't like, unless I find something here that helps, is what are you actually going to mount this on? At least the Victron Smart Shunt has got these little holes here, and you can see from this that you can actually mount this on something, and then you put your negative leads onto here. But at least you can screw this onto something to mount it properly. This one so far, I don't see how you can do that. Now obviously there are some more things here, so let's carry on looking at what's inside the box. So these would be temperature probes and things like that. Busy looking at this and wondering if this would help to mount it. And I'm not sure how this would help to mount it, to be honest. Looking at this and thinking, does this go on here? Does it go elsewhere? I'm not sure. Perhaps the idea is that this bolts onto here and it's got these 2 holes here that you can then use to put a screw through. So I'm guessing, I'm not sure about this, but I'm guessing these are too tight to take off by hand to just test the theory out. But my theory is that this would go onto here and then you'd be able to put a screw through to mount it onto something more solidly. You'd probably mount it against this here onto something and to leave this free to plug into. So that's what I'm guessing. So far the mounting would be interesting. You got a temperature probe and then your other cables, and I'm assuming that this cable would be required to go between the shunt itself and the unit here. It looks like there's no electrics in this shunt itself. It probably is sending everything back to work with this little computer here. That's fine. This, I'm assuming, without opening up the manual and looking, I thought maybe this is to power this, but it's not. It's something else that's going to be required for that. And they supply these 2 great big lug type things. Interesting. With a little spanner and a tiny little screwdriver. That's all part of the kit. They're supplying this cable here, which I assume is to, I'm assuming that this cable goes into the back here and then probably goes into here somewhere. But I would have thought that there'd be a way of mounting this completely away using it with wireless. So let's see what happens. And that's everything in the box. So what we're going to do is we're going to try and assemble this to see just how it actually works in that sense, and switch it on and try it out. Okay, this is our Victron Smart Shunt, and it's got 2 system minus and 2 battery minus. So let's connect up the 2 battery minus. Using the little spanner supplied by Junctek. Cute little thing, but I mean, not that you'd finish off with this thing. You'd use a decent ring and flat. Right, and then we've got a cable running from the Victron Smart Shunt to the Junctek shunt. So 10mm lug to a 10mm lug. So we've got from our Victron to the Junctek, and then from the Junctek coming off to the inverter. To actually power this to get it to work, we have this red lead they've supplied us with. I'll put a little crocodile clip on the end. To power this, they provide this little green thing that can plug into here. So the idea is that you put 12 volts onto VSNS over here. I'm just going to attach this loosely onto this crocodile clip and then put them onto onto this lug over here. Probably this one is the easier one to get to. Right, and we have some flashing things. We have some Bluetooth coming alive here, and we have some items flashing over here. So now I think we can connect the display. That's what I'm going to try and do. I was hoping that this was fully wireless, because in some of the other models they are fully wireless, or wired or wireless, you can choose. But it would appear that this has to be plugged in. Not particularly happy about that, because now you're going to run one more cable through in your van or whatever. So in theory, so this goes to the display, and as you can see, everything's come alive immediately. Let's take this little bit of shiny distraction off. So it's telling us it's 13.35 volts. So the Junctek Smart Shunt is here, and this is the Victron app that I've connected to. The voltages are somewhat different. I'm a little bit surprised that the Victron is showing lower voltage than the Junctek, because actually the Victron's shunt would have dropped the voltage ever so slightly. So there's a little bit of inaccuracy there, and in the past when we've checked the Victron, it's been spot on. So I have to assume that the Junctek is slightly out. This shows fairly clearly when you're actually running it. Let me just put this down. When you're running it, it says consumed amp hours. That's the most important figure, which is quite quick and easy to see on the app. This, to my mind, the voltage is irrelevant. It's lithium iron phosphate. It's going to be a very flat voltage for a long time. So I'm not really interested. Yes, I might want to see what amperage we're currently drawing, but the amp hour remaining is a small figure shown there. It's fairly small. You'd have to walk right up to the display to see it in the van or whatever. That to me is the most important figure that I want to see, and it's quite difficult to see. So yeah, let's try and connect to the app on this, and wondering what the QR is going to send us on to. So scanning this QR code that's on the little unit here sends us to an application called KG Serials, which I'm going to get because I'm assuming it's the right one. Check with my face that it's me. Right, let's open this now and let's see what this looks like. So obviously there are a few things that we need to set up now. This is showing 16 amp hours remaining. This is, I don't know where it shows remaining, but anyway, we need to find our way through this.
Connect it.
Do we actually have to connect? Is it not connected? So it says we're 80%. So let's see. Remaining capacity should be 100% at this stage. And I don't know why it says remaining 20 amp hours. The setting should be a 280 amp hour, and that's 100%. Alright, finally, it says we have remaining 280 amp hours. And I'm just busy reading through this to see various things. Elapsed amp hours. Yeah, I guess if we turn everything on and see what it does. Right, took a bit of, not too much of an effort to figure out how to connect this thing. What I'm curious to see is if I come right out of it and coming back into this KG Connect. Oh, it's connected automatically, which is quite nice. So it's connected back to this unit here automatically. So I've got this display unit, and it says remaining 280 amp hours. So we've set that in the app instead of here. So that's quite nice. So this will be able to show us. The app is quite handy in that it tells us the voltage, how much amperage is being drawn, the percentage of the battery that remains. For me, of particular interest will be the elapsed amp hour value, to know how many amp hours it's actually used, because the figure is more important than just a percentage display for me, but others may prefer to see exactly what percentage. So this would be what we call a Coulomb counter, which is, it's sort of measuring charge going in and out, and working out the difference and actually sampling it every few milliseconds to be able to say, of the 280 amp hours in here, this much has actually been used. So our next step now is to plug a heater into here and to turn the inverter on and actually get it running. But before I do that, I need to just double check that all of these cables are quite tight, because we don't want to build up too much heat at these points. So we have fully connected the Gandel 3 kilowatt inverter going through all the way there. So let's, we have a little heater at the bottom here. We're going to turn this on, but before then, so the inverter is saying 13.4 volts, which is about correct. And straight away, you can see that we've gone to 77 amps on here, 77 amps on there, 77 amps. I'm quite keen to see my Victron Smart Shunt, what it says. So it is saying 74.6 amps, so slightly less. So this is showing 77 amps, this is showing 75-ish amps. Not too bad, to sort of a 2% difference, if you like, 2-3% difference, which is more than I would want to see in terms of a difference, but not too bad. I guess when you finished with your sort of weekend stay, whether you have 10 amp hours left or 15 amp hours left or whatever, it doesn't make much of a difference. You're pretty flat. So that's the Victron showing now that we've consumed 1.6 amp hours. This, according to this, trying to actually figure out exactly what battery left. Still showing that we have 280 amp hours there. In theory, we've used 2.1 amp hours on the Victron Smart Shunt, so that should not be showing 280 amp hours left. Let's see what the application says. And I don't know why this is showing elapsed amp hours 0.060, because we should be using it up now. So they take a little bit of time to figure out exactly what these displays are actually telling us. I mean, the Victron is really simple in that you come to it, it's saying we got 98%, that's the voltage, the current at the moment being drawn, and very important, consumed amp hours. So that's, for me, is the important thing. So it's used 3.3 amp hours. I can't actually see anywhere here where it says that I have used 3 point something amp hours, and it's still saying remaining 280. It shouldn't be 280 remaining now. Should be sort of 277 remaining. So we're going to leave this running for about half an hour to an hour or so. It's drawing 77-ish amps at the moment, so that'll be a nice test to run it for 15 minutes to half an hour. Then we'll come back and we'll stop drawing power off and then recharge the battery, because it's going to be really important to see what happens when it reaches what it thinks is 0 amp hours drawn, as in 100% state of charge, whether it then counts into a negative amp hours, which was the problem with the other Junctek shunts. They were pretty useless because of that. So let's let this run for 15 minutes to half an hour, come back and see what it says. So we discovered that you have to actually turn this thing on. So there's this little on switch here on the top here, and the default is off. So when you connect everything up, it's not actually running. So you have to actually turn it on. Let's see. Okay, we've got a green on, and that then starts clocking up amp hours used and starts reducing the amount that's available. So because we figured that out a few minutes into the comparison between the two, the Victron has already measured quite a lot more consumption than the Junctek. So we're going to stop this process. We're going to charge the battery back up, and we're going to, once it's fully charged, we're then going to run these side by side again and compare and just see how similar they are or how different they are. But if I take you through this app now and what it's telling me now that everything is working. So yeah, you have to, well, the first thing, when you come in, it's not connected. So you have to click on search, find your shunt, you click on that, and that connects it up. The default is this would have been off, so it would be sitting something like that. So nothing is actually happening. You have to turn it on, and then it starts counting down. So what this is telling me, we're at 12.77 volts on the battery. We're drawing currently 75.2 amps in total. We're at 96% state of charge, which means we've used 9.57 something amp hours. That's the time left in the battery, minutes or hours left on the battery at the current rate run. This is the internal resistance on the battery. Of course, then you've got the how much power we've consumed and electricity consumption. That's the power that we're busy consuming, and that's the clocked up. So that's the Coulomb counter that's counted that up. So some pretty useful information there. Like I was saying, to me, this bottom left figure is the one that I would use, and I guess I would use the overall percentage display quite a lot. So these two things are what I'm really interested in. I do like to know what I'm drawing off in terms of amperage at any one time. The voltage, as I said, on a lithium iron phosphate is not really useful information unless you have a problem that you want to cover. So not a bad application now that I've gotten the hang of it. They should turn it on by default, in my opinion, and I suppose finding it and connecting is fine. You search and then you have to turn it on. I really think they should just turn it on by default. So we're going to stop the heater, turn the inverter off, plug in a charger and get this thing fully charged, and then we're going to do a comparison between the two shunts and see which is, well, we know the Victron is absolutely accurate because we've measured it several times. So let's see how close the Junctek is to that. So we've charged this battery right back up to full state of charge. And the thing that I really wanted to see was what happens with this. So previously I'd said that this would be the most important figure. Well, it's not actually, because this just counts current going in or out, just accumulated. For what purpose, I don't know. But anyway, it's this figure here that to me is the most important, that and the actual state of charge. So this says amp hour remaining 280 amp hours. So I've set this to 280. It's also showing the same on there. And it charged up to 280 and then stopped counting. So that's what I wanted to see, that it would stop counting at 280. So 280, 100% state of charge. It's now settled down to 13.8 volts, as we can see, not drawing any current at the moment. So this to me is quite useful. In fact, I am fairly impressed with this unit because it is telling me the most useful information, that being the remaining amp hours, the total state of charge at any stage, and then obviously it tells me the voltage, which, as I said before, is not really that important. People get hung up about voltage, but actually that's neither here nor there. These voltage curves are so flat. Current being drawn at the moment is nothing. A few other odds and ends that it tells you information that's not really of use to me. Like saying, it's this and this that I'm really interested in knowing. So pleased with this unit so far. If I look at what the Victron shunt is telling me, it's telling me very, very simple, and I like the simplicity of this. Very simple. So total amount of consumed amp hours is 0 and 100% state of charge, same sort of voltage. So it's giving me pretty much the same information, but a lot simpler layout. I do prefer this layout. It's just very elementary. Less colored, obviously, but it tells me everything that's really important. So long and the short of it, would we recommend this unit? I'll tell you the advantages are you've got this display unit that goes into your van that I quite enjoy. So you can mount this somewhere, and then you've also got access to the Bluetooth app. That's the app there. This I can see from anywhere within the Bluetooth range, and it is giving me some decent information, everything that I needed to know. So I could, if I'm in the habitation area, glance up at this, or if I'm somewhere else, load this up and have a look there. And so the versatility of having it on the display and on my mobile device is quite good. The thing that I don't like about, there are two things that I don't like about this. Firstly, you've got to have this display unit wired up, and as you can see, I haven't unwound the whole thing, but I'm guessing it's somewhere around 1.8 meters or so long. It's not a very long cable. We don't yet know if this is a standard RJ11 type cable. I've ordered a 5 meter one to see if it works with that. I'll be curious to see, but I don't like the fact that it's wired up. But that's the vast majority of units are actually wired up. The other thing that I don't particularly like is the way that they have given us something to actually mount this. This here would go onto here, and then you'd be able to mount through these screw holes here. I don't particularly like this approach. It's like they've just given it a bit of an afterthought after the whole deal, whereas it should have been part of the basic design. How is the person actually going to mount this thing onto their system? Otherwise, it's pretty good. quite like it. Right, so I've given my opinion. I'm keen to hear what Nigel thinks. So the one thing I forgot to mention with this is that you've got this temperature probe so that you can get an alternative. So within the battery, there's a temperature probe on the smart daily BMS within this battery. Not to say that the battery that you use will have one. But anyway, we know the temperature inside the battery. This tells us the temperature at wherever we mount this probe. And it is also possible using this socket here to drive a relay. So this can perform sort of the job of a fail-safe to cut the charge or something like that if voltages go over a certain amount or temperature. So you can program this unit to operate the relay. So this is something that some people might find useful, is the ability to operate an external relay based on a voltage that's too low or too high, or temperature, or a number of things, based on a number of things. So what do you think of this unit?
I quite like it. What's the cost comparison between them? I haven't even looked at the cost of the Junctek.
The Victron Smart Shunt is about, $120 or so. I don't know about current price increases because everything is going crazy at this stage. But this was about £120. This unit, they've been going up and down, well, more. They started fairly high, so about $80 or $90 or pounds, and I think they have come down to round about the £50-60 range.
Okay.
I think.
So basically half the price.
Yeah, this is half the price. The old Junctek Smart Shunt, as we know, was even less, about half the price of this.
Yeah.
And this is about half the price of this. So the only other thing with this that we still need to do is to do a proper accuracy comparison, which we'll do shortly. But yeah, I think it's quite good value for money.
Yeah. No, it seems pretty good. I quite like it. Yeah, so if you're looking for an alternative to a Victron, don't want to splash out on the $120 for a Victron, then it's probably a good option. Obviously, as we said, we'll do a comparison in terms of accuracy and let you guys know how that goes. But on the whole, we're pretty pleased with how it's looking. The most important thing, though, is that they've got the counter fixed, it would appear. So previously, we put out a video where we showed that fault in the Junctek where it just kept counting, and so you just landed up with this number on your amp hour counter that was just absurd, made no sense at all. So it didn't sort of zero at 280 amp hours or at zero or whatever the case was. So it's good to see that they fixed that.
Yeah, I think usability, this is perfectly good. It just knocks me that you've got to actually run a cable. But I guess we run so many cables, it's just one more cable.
That seems silly when they've got the Bluetooth capability. Why they don't just put Bluetooth into this? Surely it wouldn't be that much more expensive.
That's what I would have thought. Yeah, but it would have been so great to just have this base unit near the battery, and then to connect via mobile, or have this connect via Bluetooth.
Yeah. That
would have just made a huge amount of sense.
Yeah. Anyway, hope that's been helpful. Thanks for watching, everyone, and we'll see you in the next video. Cheers.
Yeah. Cheers.